So like I said before, we have already covered supplementary, complementary, and vertical angles. We just need a reminder of what they look like. So if we talked about vertical angles, so up at the top, I want you guys to give yourselves a quick reminder, a diagram reminder. When we talked about vertical angles, those were angles that were equal to each other, and you tended to see intersecting lines where you had this angle being A, this angle being B, and A was equal to B. That was what vertical angles represented. Make sure you have that written down so that you can remember that. Vertical angles, you had intersecting lines, and the angle A was equal to angle B. When we had complementary angles, you would add your two angles together, angle A plus angle B, and that would be equal to 90 degrees, and it formed an L shape. You had the form of an L shape, and one of those angles was A and the other one was B. Okay, then we had supplementary angles. Supplementary angles was very similar to the complementary set, that you would add angle A and angle B together, but then they would add up and equal 180 degrees. They tended to look more like a straight line where you had a ray coming out of it. One of those angles is A and the other one was B. And when you added those angles together, it was equal to 180 degrees. So these were the angle relationships that we learned to work with. Where's your paper? Come up and grab them. You must not have been in your seat when I was passing them around. Okay, so with that information, we're going to go ahead and work each of these problems out. For problem 1, angle A is equal to 10x plus 13, and angle B is equal to 6x plus 23. If the angles are supplementary, we want to draw a diagram, then set up an equation, and then solve for x. So we're told right now that they are supplementary. So if I draw a diagram, that means I'm going to set up a straight line with a ray coming out, and I'm going to label these 10x plus 13 and 6x plus 23. 10x plus 13 and 6x plus 23. I know that in order for me to work it out, I have to add the angles together. So I'm going to take that 10x plus the 13, and I'm going to add it with 6x plus 23, and I'm going to set that whole thing equal to 180 degrees because, again, they are supplementary. So you take both angles, add them together, and it should equal 180. From here, we have to start combining our like terms first. Who can raise their hand and tell me what is one set of like terms that I can combine together? Vincent. Well, so what are the terms that I'm going to combine together? You got the answer correct. So what did you do? Added what? How did you get 16x? What two terms did you add together? There you go. So he added the 10x plus the 6x. He added those two values together. 10x plus the 6x is going to give him 16x. There's two other terms that we can combine together. Christopher?
13 plus 23.
Very good. 13 and 23. We can combine those two together as well. We have a positive 13 and a positive 23 that when we combine them together, we're going to get a positive 36. So we now have 16x plus 36 is equal to 180. It's now just a two-step equation for us to solve. Who can remember what is the first inverse operation? Angel? Very good. We're going to subtract 36 from both sides first. Remember, our inverse operations means we are doing opposite operations in order to get that x by itself. So we subtracted 36 from both sides. That then gives us 16x is now equal to 144. From there, what do? We've got 16x is equal to 144. What is the inverse operation that I need to perform? Like, what's the opposite operation that needs to be involved here? Division. We need to divide both sides by 16. Okay, so in your calculators, you should be dividing 144 by 16. What do we get when we divide that? 9. Okay, so we're going to get that x is going to be equal to 9. X is going to be equal to 9. Okay, we're going to do the exact same thing again with those same two angles, but this time we're going to do complementary. Complementary. So if we look back up here, complementary, the diagram forms that L shape. So I'm going to form an L for my diagram. And I'm going to split the L up so that one of these angles is that 10x plus 13. The other angle is 6x plus 23. And I'm still going to set it up the exact same way that I did my supplementary, but instead of it equaling 180, what am I going to set it equal to? 90. Very good. So we've got 10x plus the 13. We're going to add that with my second angle, that's 6x plus 23, and that whole thing is going to be set equal to 90 because it was complementary. We still do the exact same thing that we did before. We combine those like terms. We're still going to combine the same set. That 10x and that 6x is still going to come out to 16x. The positive 13 and the positive 23, they're still going to come out to a positive 36. But this time it's all set equal to 90. So we follow the same process. The first thing that we want to do is subtract 36 from both sides. That leaves us with 16x is now equal to 54. And then we would divide both sides by 16. What's 54 divided by 16 going to give us? 3.375. Good. It's okay to get decimals. Okay, so I'm going to change problem 3 a little bit, only because you guys haven't learned how to work with equations where variables are on both sides. That's not a skill set that you had to do. This was something that we did with our gifted blended classes, and that was a AKS that they needed to know. So what I want you guys to do is I want you to keep the 10x plus 13 just as it is, and you're going to change angle B. Let's see here. Change angle B to 63. So put angle B is going to be equal to 63 instead. Okay, so angle A is still 10x plus 13. Angle B, we're setting it equal to 13 or 63, and this time we're talking about vertical angles. Remember up here, I said vertical angles are equal to each other. So when I draw my diagram, I'm going to draw these little intersecting lines here. One side of these is going to be 10x plus 13. and then the other direct opposite side is going to be 63. And when I create my equation, it's going to be 10x plus 13 is equal to 63. So we've set the two angles equal to each other this time. Similar process for solving. What is the first inverse operation that I have to do to solve? Subtraction. Good. Subtract 13. We're going to subtract 13 from both sides of the equal sign. Okay, that leaves us with 10x on one side. And what is 63 minus 13? 50. Okay, and then our last step is to do what? Divide by 10. Good. So we're dividing both sides by 10, and we'll get that x is going to be equal to 5. Okay? If we take a look at this last problem, angle A is 14x minus 18. Angle B is 5x plus 13. I'm already telling you what x is going to equal. X is going to equal 5. I want to know what relationship do those two angles have. Are they vertical, complementary, or supplementary? In order to figure that out, what I need to do is I'm going to take, I'll do this in orange. I'm going to take this value of x equaling 5, and I'm going to substitute it in wherever I see an x. You're going to substitute. That means you're going to take the value 14x minus 18, and you're going to replace the x with a 5. So now it's going to be 14 times 5 minus 18. What's 14 times 5? 70. What's 70 minus 18? 52. Okay, so here's angle A. Angle A is equal to 52. We're now going to do the same thing for angle B. Angle B was 5x plus 13. But now we're going to replace the x with what value again? 5. We're going to replace that x with a value of 5. We're going to do 5 times 5 plus 13. Guys, what's 5 times 5? 25. What's 25 plus 13? 38. Good. So now the first thing I'm going to ask myself, are these vertical angles, are they equal to each other? No. They're not equal to each other, so they can't be vertical angles. So the next thing that I'm going to try to do is add them. Add them together and see if I get 90 or 180. When I add these together, what do I get? 90. So that means that they are complementary. Complementary angles equal 90 degrees. So these are complementary angle relationships. Okay, get that down quickly and then go ahead and turn it over to the next page. I apologize, I accidentally made them into 3 sheets instead of having a back-to-back. So just go ahead and flip it to the next page. So on our next page, just a real quick reminder of angle classifications and side classifications for triangles. We're talking about triangles today. So there are 3 ways that you can classify triangles by angle measurements. If it's an acute triangle, that means all of your angles are acute. Who can recall, what does acute mean? Sophia? They're small. Yeah, they are small. If it is an acute angle, that means it is less than 90 degrees. If it's an acute angle, then all the angles are less than 90 degrees. When we're talking about a right triangle has exactly 1 right angle, and a right angle is equal to 90 degrees. And if we're talking about an obtuse angle is big, right? Think obese. It's big. It is greater than 90 degrees, but obviously less than 180. Okay, then we've got our sides classification. You can classify a triangle based off of the sides that it has. If a triangle has absolutely no sides being the same, if all three sides are different measurements, then we call it scalene. If at least two of the sides are equal, we call it isosceles. And if all the sides are exactly the same, that's called equilateral. Equilateral. So think equal, equilateral. All three would be the same. And based off of these characteristics, we can now indicate our triangle sum theorem. It's important to know the types of triangles because sometimes they might give you a question where they tell you it's a right isosceles triangle, or it's an acute equilateral triangle. That information helps you to solve if you've got a missing angle measurement. And the way that we can solve with angles is no matter what kind of triangle you have, when you add all three angles together, it's always equal to 180 degrees. Every single triangle, whether it's equilateral, scalene, obtuse, right, it doesn't matter the type, they all equal 180 degrees. Is that clear? Okay, so it makes it really easy when you're solving for missing angle measurements. So once again, one more time, if we add all three angles of our triangles together, it's always going to equal 180 degrees no matter what. So when we're taking a look at the following examples, Marlene, when we're taking a look at the following examples, for problem number 1, we have the following triangle. This measurement is labeled X, this measurement is labeled 68, and this one is labeled 47. Based off of the triangle sum theorem, if I take each of these angles, so we'll say that this is angle X, let's go ahead and state that this is angle Y, so 68 we'll label it as angle Y, and then angle Z we'll go ahead and label that as the 47. If I take all three of these angles together and add them up, it's going to equal 180 degrees. So when I create my equation, it's X plus 68 plus 47, and it's equal to 180. Before I start solving, I should probably combine my like terms. Kayron, taking a look up here, tell me what like terms I can combine together to simplify. Thank you. 47 and 68 can be combined together. It's a positive 68 and a positive 47. When we add those together, we're going to get a positive 115. So we now have X plus 115 is equal to 180. From there, we can go ahead and solve for X. What's the inverse operation that I need to do? Angel? Good. We're going to subtract 115 on both sides. If I recall, Angel, this was like your best unit equations, wasn't it? Yeah. So once we've done that, we'll get X by itself. X is going to be equal to 65 degrees. If you take a look at problem 2 has angle A, 41, and then it has this box. Who can remind us what does that box mean? What measurement is that little square, Vincent? 90 degrees. That little itty bitty box that's written right here inside of the angle means that this angle is 90 degrees. You always want to write 90 degrees in when you see that box so that you remember that there is an angle measurement there. Same thing with problem 3. You've got a box again. We should go ahead and naturally just write 90 degrees in there so that way we remember. Okay, what I want you to do is for problems number 2, 3, and 4, I want you to solve for the missing measurement. Go ahead and do problems 2, 3, and 4 on your own. All right, let's take a look at problem number 2. Again, when we set up this equation, we have angle A plus the 90 degrees plus the 41 degrees, and the whole thing is going to be set equal to 180. Okay, first thing that we need to do is combine these like terms together. So we're going to combine that 90 and that 41. That's going to come out to 131. So we now have the equation A plus 131 is equal to 180. Our last step is to subtract 131 from both sides. And what do we get for our value of A? 49. So we get 49 degrees for our value of A. Okay, let's take a look at problem 3. Problem 3, when we set this up, we set it up as x plus the 90 degrees plus the 39 degrees. The whole thing, again, is always going to be equal to 180. All triangles are always equal to 180 degrees. We'll combine these terms together. When we combine the 90 and the 39 together, that gives us 129. So we now have the equation x plus 129 is equal to 180. Our last step is to subtract 129 from both sides. When we do so, we're going to get that x is going to be equal 51 degrees. Good. Okay, and then problem number 4. Same process. We have the value of x. We're going to add it with 100 degrees. And then we're going to add it with the 55 degrees. And the whole thing is supposed to be set equal to 180. When we combine those measurements together, that 100 and that 55, it gives us a positive 155. So we now have the equation x plus 155 is equal to 180. When we solve, we're going to subtract 155 from both sides, and what do we get as our measurement for x? 25. So x is going to be equal to 25 degrees. Okay, very simple and easy when only one angle is missing. Is it always going to be just one angle missing? No. And sometimes it might be expressions instead of just a value of x. So let's go ahead and take a look at the very last page. With the last page, that's set up a little bit different. If you're looking at problem number 5, this is 4x, this is 6x, and this is 2x. So we have angles 4x, 6x, and 2x. It's still the same concept though. We still take each one of these angles and add them together and set it equal to how many degrees? What does it always set equal to for a triangle? 180. It's always set equal to 180. We just take each one of these angles and add them together and set it equal to 180. We still have to focus on combining like terms first. So it happens to be that all of these are like terms because they all have the variable x. So what is 4x plus 6x plus 2x going to give us? 12x. So we now have 12x is equal to 180. What do I do to solve? Divide. Good. So we're going to divide both sides by 12. And what do we get for the value of x? 15. So x is going to be equal to 15 degrees. It's the same thing for here. Problem 6 is a little bit more extensive. We take each one of these angles. This is x plus 10. This is 2x plus 20. And this is 2x minus 5. Each one of these is the same thing. So I'm going to take my first angle, x plus 10, and I'm going to add it with my second angle, which is the 2x plus 20. And then I'm going to add it with my third angle, 2x minus the 5. And the whole thing is set equal to 180. I combine my like terms first. I'm going to first focus on the variables. I've got x plus 2x plus 2x. What coefficient is in front of that x? A 1. There's a 1 in front of it, so I've got 1x plus 2x plus 2x. When I combine that together, I get 5x. Okay, then I've got my constants, my numbers. I have a positive 10, I have a positive 20, and a negative 5. Very good. Who said that? Good job, George. Negative 5, because of the fact that it has a minus sign in front of it, that indicates that it is negative. So when we're working it out, we're going to have a positive 10 plus the 20, and then minus the 5. 10 plus 20 is 30, minus 5 is 25. But it's a positive 25, so we're going to put a plus sign in front of it. And that whole thing is still set equal to 180. Now we follow the process of solving by doing our inverse operations. The first thing we do, just like Angel was saying, we first have to subtract. We're going to subtract 25 from both sides. That gives us 5x is now equal to 155. And then our last step is to divide both sides by 5. Okay, when we do 155 divided by 5, we're going to get x is equal to 31. I want you guys to try problem 7 on your own. Try problem 7 on your own. All right, who's finished? Ezra, what'd you get? For problem 7. 70. Very good. So let's go ahead and go over it. We have our angle measurements. We've got x. We have x plus 2. And then we have 38 degrees. When we add those together, we add the x plus 2, and then plus the 38. And it all gets set equal to 180. We can combine the like terms. We've got x plus x, which just comes out to 2x. We don't have any, we have like terms of 2 and 38. When we add those together, that comes out to a positive 40. So we have 2x plus 40 is equal to 180. Then we just solve. We would subtract 40 from both sides first. That leaves us with 2x is now equal to 140. And then at the very end, we would divide both sides by 2, and we would get x is equal to 70. Okay, our last problem here, remember I told you sometimes they might not give you a diagram, they might just give you words. Here it says that we have a triangle that is a right isosceles, So if I were to draw that, I know I have to have a right angle, and because it needs to be isosceles, that means 2 of the sides have to be equal, which also means 2 of the angles are going to have to be equal. So if this is angle x, then so is this one. They both are going to be equal angles because we have equal sides. The only other angle is 90 degrees. I can't have 2 angles being 90 degrees because, guys, if I try to draw a triangle with 2 90-degree angles, here's a 90-degree angle, and then, here's another 90-degree angle. Can I make a triangle out of that? No. It's impossible to make a triangle with 2 90-degree angles. So only one of the angles can be 90 degrees. The other 2 must be equal angles to create that isosceles measurement. Okay, with that in mind, we can go ahead and solve for that. We can set this up as x plus, what is this going to be again? 90. This is 90 is equal to 180. Again, this right angle is 90 degrees. So when I combine my x and x, I get 2x. So I have 2x plus 90 is equal to 180. What's the first inverse operation? Subtract. We're going to subtract 90 from both sides. That's going to leave us with 2x is now equal to 90. And then our last step is to divide. We'll divide both sides by 2, and we find out that the measurement for each of those angles is 45 degrees. Okay? All right. You have plenty of time to be able to get on and do your assignment. It is a single IXL, and I want you to go to a 100. A 100, not to a 70 today. You're going to go to 100. It's easy. It's just solving for a missing angle.